Alright, what we're looking at next is graphing a piecewise function. So in this example, what we're going to do is we're going to plug enough x values in for each piece to determine the shape for that part of the graph. Pieces could go from negative infinity to a certain x value, be a segment between two x values, or go from one x value to positive infinity. So we'll look at an example. We're going to graph our function. F of x is equal to x plus 1 for those x's that are less than negative 2. F of x is equal to x squared for those x's from negative 2, greater than or equal to that, but less than 2. And then f of x is equal to negative 3 for the x's that are going to be greater than or equal to 2. Now, first of all, we'll start with this one right here. Now, hopefully you should be able to look at the function at this point in time and realize that it is linear. So what we're going to do is we're going to plug in values here. Okay, now if you were to graph this on a number line, what you would do is you'd start at negative 2 and you'd have an open circle and you would shade to the left. So what we're going to do is we're going to do that exact same concept when we're making a table. So what we're going to do is we're going to start with negative 2, and all we're going to do to get our y value is plug it in here. Well, negative 2 plus 1 is negative 1. The only thing is when we graph that, we're actually going to use an open circle for that graph. So we'll come down here and we'll say negative 2, comma, negative 1. And what we'll do is we'll draw an open circle at that point. Okay, so basically what that means is that it's going to go right up to this point but not include that point. We don't start at negative 3 because there are a bunch of numbers between negative 3 and negative 2 that are included in the graph that wouldn't be there if you just used a closed circle. But so I need some more points. We're going to plug in negative 3. When you plug in negative 3, you get negative 2. So we graph negative 3, comma, negative 2. When you plug in negative 4, you get negative 3. And then lastly, plugged in negative 5 to get negative 4. Now, if you notice, our graph is going to be a line. Sorry, this tablet's going to be... That wasn't as bad as I thought it was going to be. Alright, so this is the shape of our line. Now, what it actually is actually a ray, because it doesn't go on forever. We are limited by the x's that we can plug in. So we can only plug in the x's that are less than negative 2. So that's why it doesn't go this way forever. And what you'll see is in a piecewise function, you won't have graphs that overlap. You won't have a graph here, and a graph here, and a graph here, because it is a function, so it still has to pass the vertical line test. Okay, now we're going to move on to this part. Well, this part is just going to be a segment. It's going to be between negative 2, where negative 2 is included, and positive 2, where positive 2 is not included. So over here, I'm going to plug in enough values to get the idea of what the shape of the graph is going to look like. When I plug in negative 2, again, the function is telling me to square it. Negative 2 times negative 2 is a positive 4. When I plug in negative 1 squared is positive 1. When you square 0, you get 0. When you square 1, you get 1. When you square 2, you get 4. Okay, so we're going to come over here and we're going to graph these. Now, if you notice right here, negative 2 is included in this set. So when I graph this, I'm actually going to use a closed circle. 2, 3, 4. I'll put a closed circle right there. Okay, that represents that point is included in our solution set. When I graph negative 1, comma 1, there's my dot, and 0, comma 0, 1, comma 0. Now when I graph 2, comma 4, as you can see, that point is not included in our set. So if you graph this on a number line, you'd have an open circle here. So what we're going to do on our graph, we're going to put an open circle also. And that basically shows that our graph goes right up to that point, but that point is not included in our solution. So there you go. That's that section of the graph. Notice it does still pass the vertical line test anywhere, so your graph's not going to overlap. This is actually a section of our graph. Okay, so it would be kind of like a line segment if it were linear, but it's just a section. It doesn't go on to infinity like most parabolas would do. And then lastly, we're going to have to graph this last part. Well, this last part is actually a constant function. So no matter what x is, we'll get a y value of negative 3. So this will be negative 3. This will be negative 3. This will be negative 3. And this will be negative 3. Anytime you have a constant function, that's what's going to happen. Now, because 2 is included in this set, we'll actually use a closed circle. So 2, comma, oops, that's positive 3. 2, comma, negative 3 will be right here. And then all the other x's will have the same function value. And you can see that's basically why we get a nice little horizontal line when you graph a constant function. That's graphing a piecewise function. Again, a couple things. Make sure that whatever values you have in your intervals or your inequalities here, if there is no bar, you'll graph that ordered pair with an open circle. If there is a bar, you'll use a closed circle. Remember that your graphs have to pass the vertical line test, so you won't plug in the same x into more than one, and you just graph it in its parts.